Hello everyone. Today we're going to start the sections that deal with factoring. We start with 14.1, which is the greatest common factor and also factor by grouping. We have two objectives in this section. We're going to identify the first and the most important type of factoring called the GCF, or the greatest common factor. And then we're going to also discuss what factor by grouping is. The greatest common factor is called the GCF, and it's called the greatest because you factor out the largest quantity that can be factored from each term. What does that mean? Well, let's say I have two terms here, such as 6x plus 12. Now, if you look at these are two terms. Terms, by the way, are identified by separation of a plus or minus. So the 6x is a term and the 12 is a term because they have a plus sign between them. So if you take a look at these two terms, and what is the largest factor that is common in those two? Well, if you think that 2 is common because 2 goes into 6 and 2 goes into 12, sure, 2 is a common factor, but is it the greatest common factor? No. The greatest common factor, or the GCF, for these two terms is 6. That's why it's called the greatest. Now, factoring the GCF is going to look like this. You have those two terms, you're going to factor out the 6, and then you're going to open parentheses, and then you're going to see what's left in the two terms. So when I factor out a 6 from 6x, I'm left with x, and then you have the sign in the middle, which is the plus, and then when I factor out a 6 from 12, I get 2 left. Notice a couple of things here. The whole purpose of factoring is to turn an expression like this, which has two terms, as we've discussed before, into an expression like this, which has factors. It's very important to understand the mathematical language and to know what it means. You will need to know those. Factors, that's why it's called factoring. The difference between terms and factors is that, as we said before, terms are separated by addition or subtractions, but factors are separated by multiplication. If you look at what we have here, we have a factor of 6 times a factor of x plus 2. There's multiplication that separates these two now. So now we have factors. One factor is 6. The other factor is the whole quantity x plus 2. And that is the whole idea of factoring from here to here. We have turned the addition and subtraction into multiplication. Now, just a quick note on how we've accomplished this. So we have talked that the greatest common factor is 6. So you factor out the 6. And then you open the parentheses. Now, how do I get the stuff that's inside the parentheses? Well, technically, what we actually did is we went up here to that 6x, and we said, okay, if I'm factoring out a 6, I can divide by that 6 here. 6x divided by 6, that's what gave me the x, because the 6's will cancel with division. And I also went to that 12, and I said, okay, if I factor out the 6, I'm going to divide this by 6. And then 12 divided by 6 gives me 2. So that's how you get the what's inside the parentheses. Also notice the following. very important to understand that factoring is not simplifying. Factoring is not simplifying. If you look at those two expressions that we have, those expressions are exactly the same. 6x plus 12 and 6 parentheses x plus 2, they are exactly the same. This is not simplifying. None of them is simpler than the other. So if I give you this and say simplify, you're going to say there's nothing to simplify. I cannot combine any like terms here. Okay, so factoring is not simplifying. It is merely rewriting the same expression in a different way. And when you factor, you have to make sure that the expression that you wrote is equivalent. Well, how can I make sure that this is the same as this after I've factored? Simple. You can reverse the process. Okay, you can expand or distribute. So distributing is the reversing of factoring. If I distribute this, 6 times x is 6x, 6 times 2, so plus 12, then I know that I factored correctly because I have the same exact expression that I started with. So these are all very important points about factoring. If you've missed any of those, or if you want to pause and rewind and write them, these are all concepts. It's very important to understand them. We need to know what the difference is between terms and factors, why do we factor, and how we can make sure that we factored correctly. Okay, let's review some more points about factoring the GCF. So when I want to factor out the GCF of a polynomial, I'm going to read this to you and then we're going to see examples for it to be clearer. First, we're going to factor out the numbers or the constants. Just like in the last example, we factored out 6. That's a constant. But we may also have some variable common factors such as x or x squared or x to the power of 3 or so forth. Well, if I have an expression such as 2x squared plus 5x to the power of 3, what is the greatest common factor here? Do we have a common factor with the constants? No. Now take a look at the variables. Do we have a common factor of the variables? Yes, they both have x's. Well, which one of those am I going to factor out? Well, that's what number 2 here talks about. We're going to factor out the GCF of each variable based on the lowest exponent. So in this case, what I'm going to factor out is x squared. That's the one with the lowest exponents. I cannot factor out x cubed, okay? Because x cubed does not go into x squared. X squared goes into x cubed because it's smaller. So the second step is factor out the GCF of the variable with the smallest or the lowest exponent that is common. Next, we are going to divide each term by the GCF and write what remains inside the parentheses. Such is what I've showed you before. So if I factor out x squared from here, I open the parentheses. How do I know what's inside the parentheses? You can take the first term divided by x squared. What does that give us? Yep, 2. And then plus. And then divide this by x squared. 5x cubed divided by x squared. So that gives me 5x. Okay. The x cubed, when I divide it by x squared, I'm going to have an x left. And this is going to be our final factored product. Here's another note. Please understand that factoring the GCF is, or it could look like it's a very simple process. However, I can tell you right now that it is the one that everybody makes mistakes on because you forget about it. Now, in this section and in the upcoming sections, I can tell you we're going to learn about 9 different factoring methods. Each of them is going to be used in a specific case. The first one that we're learning today is the most important factoring method, and that is factoring out the GCF. It's the simplest. But the important thing about GCF is that it has to be used first, always first, no matter what other method of factoring will be used afterwards. So GCF is always first. The most important factoring in your life is GCF. And I'm going to remind you after we have piled on a whole bunch of factoring methods and you may forget to factor out the GCF first. Okay, so always factor out the GCF first. Here are some examples. I will encourage you guys to go ahead and try to factor each of those using the method of GCF. Do as many as you can. Pause the video at your will. Okay, if you want to do one at a time and then pause after I show you each one, that's fine. But I want you guys to try each of those on your own before you see how I did each of them. And you can pause and play however you want to see if you got the right answer. Okay, let's take a look at our first one. Factor the following expressions. We have 2x plus 2. Our greatest common factor here is going to be 2. When we factor this out, we factor out the 2, we open the parentheses, and then remember that what we get here is a result of division. If I divide this by 2, I get x, and then we have plus in the middle. And then if I divide this by 2, and this is very important, 2 divided by 2 is not 0 or blank. Anything divided by itself is 1. So we have x plus 1. And if you want to make sure that your answer is correct, you can expand or distribute, and then we'll get 2x plus 2 again. So we know that our factoring is correct. The next one we have is 13x cubed minus 2x. So let's take a look at the constants first. We have 13, we have 2. Is there any common factors here? The answer is no. What about the variables? We have x cubed, and then we have x. So yes, there is a common variable here. So what can we factor out? Remember, you factor out the variable with the lowest exponent, and that has to be this x, because it's the equivalent of x to the power of 1. So that has the lowest exponent. You cannot factor out x cubed. So the GCF for both of these terms is x. When I factor out the x from this one, if I divide this by x, I get 13x squared. X cubed divided by x is x squared. There's going to be 2 of them left, minus 2x divided by x is 2. And once again, you can distribute to make sure that you have the right answer. The next example we have is 5x to the power of 4 plus 15x cubed. Let's take a look at the constants. 5 and 15. Can we factor out a greatest common factor? Yes, we can factor out a 5. But then also let's take a look at the variables. We have x to the power of 4 and we have x cubed. So we can take out the variable with the lowest exponent, so we can also factor out x cubed. So the GCF is 5x cubed. Let's open parentheses and see what we have left. If I divide this by 5x cubed, the 5's are going to cancel. X to the power of 4 divided by x cubed, what do I have left? Well, if I have 4 of these, x to the power of 4, and then I have 3 of those on the bottom, x cubed, then 3 of those are going to cancel, and I'm only going to be left with 1 of the x's. So what we have left here is x plus, if I divide this by 5x cubed, 15 divided by 5 is 3. X cubed and x cubed will cancel, so the variables will go away. So this will be our final factoring. The next example we have is 7x to the power of 7, y to the power of 8, plus 28, x squared, y squared, z to the power of 5. So let's take a look at the GCF. What can we factor from those? First, here are the constants, 7 and 28. We can factor out as 7. Next, let's take a look at the like variables. We have an x to the power of 7. We have an x squared. The one with the lowest exponent would be x squared, so we can factor that one out. Next, we have the y's, y to the power of 8 and y squared. Same concept here, we can factor out y squared. Next, we have z to the power of 5 here, but there is no z in the first term. So there is no common factors when it comes to the z's. So we cannot factor out because it's not a common factor in both. So here's our GCF. Let's use, again, what we've done before. So we can divide both of these by the GCF. The first one, 7's are gone. X to the power of 7 divided by x squared. What do we have left here, guys? So if I have 7 of those, and I have 2 of those on the bottom, then I can cancel 2 with 2. How many x's do I have left? Well, the answer is 5. X times x times x times x times x. This is x to the power of 5. Now let me remind you of something that we have learned in previous classes, and that has to do with dividing exponents, called the quotient rule. The quotient rule says if I have x to the power of 7 over x squared, when I divide, it says that I subtract the exponents. That was the quotient rule. X to the power of 7 divided by x squared is going to be x to the power of, and then you subtract the exponents. 7 minus 2 is 5. This is the explanation why the quotient rule is the way it is, but nevertheless, it's one of the rules for exponents that we should know by now. Okay, so we have x to the power of 5 left over here. Let's take a look at the y's. We have y to the power of 8 divided by y squared. So now we can use the quotient rule, since I reminded you of it. and that is going to give us y to the power of, and you subtract those exponents. 8 minus 2 is 6. Then plus, let's take a look at the second term. 28 divided by 7, that leaves us with 4. X squared divided by x squared, those two are going to cancel each other. We're going to get 1. Y squared divided by y squared also will cancel. We're going to get 1. But then what we have left in the numerator is z to the power of 5. Go ahead and also try to reverse this operation. Try to expand or distribute this in there to make sure that you have the correct factoring and you're going to get the right answer. And if you have been stuck at any point so far, please pause the video, do this last example on your own, and make sure you can get the right answer. Okay, let's take a look at what we have and what the GCF is. First, constants. We have 16, we have 12. We can factor out 2, but it's not the greatest common factor. 4 is the greatest common factor. Then w to the power of 4, w to the power of 9. Use the one with the smallest exponent, so we can factor out a w to the power of 4. Then we have x to the power of 5 and x to the power of 7. We can factor out x to the power of 5. Then we have y squared, no y on the other side, so that's it, we cannot factor it. So let's factor out 4 w to the 4th power, x to the 5th power, open the parentheses and see what we have left. So if we divide this by 4w to the 4th, x to the 5th, 16 divided by 4, that's going to leave us with 4. W to the 4th divided by w to the 4th, they're going to cancel each other. X to the 5th power, x to the 5th power, cancel each other. And then we're just going to be left with y squared. Then we put the sign in the middle, minus, divide again. Twelve divided by 4 is 3. W to the 9th power divided by w to the 4th power, subtract the exponents, that gives us w to the 5th power. X to the power of 7 divided by x to the power of 5, that's going to leave us with x squared. And that would be our factored form. So the first type of factoring that we've learned, number 1, is how to factor using the GCF. The second type of factoring we are going to go over is called factor by grouping. And the importance of factor by grouping is that because it's the only way we know how to factor 4 terms. That's the key thing here that you have to remember. Whenever you have 4 terms, the only way that we know how to factor that is through factor by grouping. And factor by grouping works in 2 steps. First step is to take the 4 terms and make them into 2 terms. That's step number 1. Step number 2 is take the 2 terms and then turn them into 1 term, or the final factor. Okay, to explain the two steps, we're actually going to go backwards. I'm going to show you how to do the second step first, and then we're going to go over the first step. And to kind of give you an example, let's take a look at what we have here. Those are two terms. Here is one term, and then it's separated by a minus sign, and then all of that is one term. Remember that terms are separated by addition and subtraction. Please don't think that this, makes it like three terms or anything like that. There's a multiplication right here in the middle, which bounds those two and makes them one term. 3 times y times 3x plus 7. So those are three factors here, one factor, two factor, and this whole parentheses is one factor. So because they're all multiplied together, this is one term, but then we have a minus and then a whole other term there. Okay, so if I have something like this, how do I factor it? Well, notice that we have a common factor, and the common factor is this whole factor right here. This whole 3x plus 7 is common in both of these. So just like we did with the GCF, what you can do is factor out this whole common factor, but in this case, it's a whole thing in parentheses. The whole 3x plus 7 is a common factor that we're going to factor out. Okay, and then after you factor out the GCF, you typically open the parentheses and then you see what's left. How do I find out? Well, here's the first term. I can divide that by 3x plus 7. And here's the second term. I can divide that by 3x plus 7. And I can see what I have left. So the 3x plus 7 factor on top cancels the whole 3x plus 7 on the bottom. And all I have left here is 3y. And then the sign minus. And for the second term, the 3x plus 7 cancels with that. And all I have left is 4z. And that is the second step in factor by grouping. So let's practice this step a little bit, and then we're going to go into full terms in factor by grouping that we can use. So take a look at those two examples and see if you can go ahead and apply what we have just learned here. Pause the video, try this on your own, and then come back and play it. Okay, so hopefully you recognize that we have, here's one term, here's another term separated by this plus sign, and that the GCF in both of these is those factors in the parentheses, u minus 6. So the whole thing is the common factor here. So if I factor this out, u minus 6, it has to be in parentheses because it's a whole factor together. And then I can open my other parentheses and see what we have left. If I divide the first term by u minus 6, that'll cancel. And what I have left is 7u squared. Plus, if I divide the second term by u minus 6, this cancels and I have 3 left. So this gets factored as that. The second example is a little bit more tricky, but once again, you should try to recognize that here is one term, here is a second term. Now this is tricky because essentially those parentheses are really not necessary. There's nothing in front of them. There's no minus sign to be distributed. There's no number like 2, for example, that we have to distribute into the parentheses. So those parentheses are, so to speak, superficial. Like this example here could have been written as that 6x times z plus 6 plus z plus 6. Okay, that's the same thing. Exactly the same thing. I can get rid of those parentheses and write it as that. So why is there parentheses here? Well, the parentheses here serve a purpose to show you that you can use those two here, this z plus 6 and these z plus 6, these are common. You can use that whole expression z plus 6 as the greatest common factor. So let's see what happens when I do that. So because I recognize that those two are common, I can factor out the whole z plus 6. Then once again, I can open the parentheses and see what I have left. So I essentially choose to separate this as one term and this as one term, even though I've explained it really wasn't. Okay, so what do I have left from these two terms that I've chosen? If I divide this by z plus 6, they will cancel, and then I am left with 6x, then the plus sign. Now, the tricky part continues. What happens if I divide this by z plus 6? Think about it. Does it disappear? Does it go away? Does it become 0? What is z plus 6 divided by z plus 6? Well, what is anything divided by itself? What is anything divided by the same thing? What is 2 divided by 2? What is 5 divided by 5? What is z divided by z? Anything divided by itself is 1. It's not 0, it's not blank, it's 1. Z plus 6 divided by itself is 1, divided by itself is 1. So we have a plus 1, and this one is very important, and it's one of the most common mistakes on the tests. Hopefully everybody understands where that comes from and why. Okay, as we've mentioned before, what we just did is the second step in factor by grouping. In most cases, our problems are not going to start at that step. Our problems are going to start a step earlier, and that is when we have 4 terms, such as the example that we have here. Okay. Our problems for factor by grouping start with 4 terms. Here's term number 1, term number 2, term number 3, term number 4. Please always recognize that they're separated by addition and subtraction. That's why they're separate terms. Okay, so how do I go from the 4 terms? How do I do the first step that leads me to the one that we just saw? Well, what you do is you group each 2 terms together. That's why it's called grouping. So here are 2 terms. You are going to group these 2 together. You're going to consider those 2, and you're going to consider those 2 together. Okay, so I put them here in colors. So the 9xy plus 21y, I'm going to group them, and the positive 12xz plus 28z, I'm going to group them. Then what you do is from each group, you factor out the GCF, which we've learned earlier. So take a look at these 2. What is the GCF there? Well, from the constants, we have 9 and 21, so we can factor out a 3. x in the first term, no x here, cannot factor out, but we have y and y, they are common. So the GCF in the first group is 3y. What is the GCF in the second group? Well, that'll be 4z. And what you do is from each group, you factor out the GCF separately, okay? So I'm going to factor out the 3y from here, and I'm going to open my parentheses like I always do. What do I have left? Well, from the first term, I'm going to have 3x plus 7. Okay, what about the second group? I'm factoring out a 4z. Now, please note that we're factoring out a positive 4z, okay? You can factor out a negative as well. Not in this case, but we're factoring out a positive 4z. It is crucial that at this step, you have the sign with it, plus 4z. This sign is very, very important. I'll explain to you why in a minute. Okay, so if I factor out the positive 4z from the second group, what do I have left? 3x plus 7. Now, why is that plus sign so important? The plus sign is so important because recall what I've mentioned earlier, factor by grouping starts with 4 terms. Our first step is to turn the 4 terms into 2 terms. Here is one whole term plus here is one whole term. If you don't have the plus sign there, if this is just blank, that means multiplication. Okay, that means you don't have 2 terms. So this plus sign or the minus sign, if we factor out a negative, is very important to separate the 2 terms. And then this should look familiar to you because this is the step that we have practiced before. From these two, we have a common factor of 3x plus 7. So I can factor out that 3x plus 7 and then open the parentheses and I can see what I have left. In the first term, if I divide by 3x plus 7, this cancels and I have 3y. And then plus, that plus is very important. And from the second term, if I divide by 3x plus 7, those will cancel and I'm left with 4z. And our factor by grouping is now complete. Right here is the last step or the final grouped factoring, and that is one term. So as I explained to you, factor by grouping, we start with 4 terms. After one step, we get 2 terms, and then our final step is the final factored form with only 1 term. Go ahead and try the first one right here. Do this on your own, factor it by grouping, pause the video, and then come back when you are done. Okay, let's take a look at the steps together one more time. We start with 4 terms. The first thing we do is group each 2 terms together. Here's one group, we're going to group these 2. Here's the second group, we're going to group these 2. And we are going to figure out what the GCF is from each group. So looking at the first one, what is the GCF? It is x squared. Looking at the second group, what is the GCF? It is 2. All right, so let's go ahead and factor out the x squared from the first group. 4x cubed divided by x squared, that leaves us with 4x minus 5x squared divided by x squared, that leaves us with 5. What is the GCF from the second group is 2. Please, again, recognize it's a positive 2 that we're factoring. So we're going to have a plus and then the 2. Let's see what we have left. 8x divided by 2 is 4x, minus 10 divided by 2 is 5. So now we have our first step that contains those two terms now. And we can recognize that we do have the same GCF here. 4x minus 5 can be factored out. Then let's see what we have left. If I divide this by 4x minus 5, I am left in the first term with x squared. And then the plus sign, that's why it's very important, goes here. And for the second term, those will cancel and I have 2. So this is the final factored form for factor by grouping. Okay, let's take the second example together. And I will discuss that with you, and then I'll have you do it on your own in a minute. But we can recognize now the 4 terms, so we need factor by grouping. If I factor the GCF from here, what would it be? What is the greatest common factor in those two terms? Well, it is 5y cubed. Okay, so if I factor out the GCF from these two terms, please pay attention because this one's tricky. I'm going to get 4y minus 3. Okay, so far so good. Here is the second group. What is the GCF here? Well, let's assume that we are just going to factor a 2 or a positive 2. Let's see what happens if I factor out a positive 2. If I factor out a positive 2, I'm going to put the positive with it, the plus 2, and then I'm going to open parentheses and see what we have left. What happens if I divide this term by 2? Well, please understand that this negative belongs to that term, okay? The sign always belongs to the term that comes after it. So this is a negative 8y. If I divide this by 2, I get negative 4y. What about the second term? If I divide this by 2, I get a plus. 6 divided by 2 is 3. Now, is this wrong? Look at it. Look at the two terms that we have now. Well, technically, we didn't do anything wrong. We factored out a positive 2. 2 is a common factor. But the issue here is that it's not useful. What we end up with is a 4y minus 3. What we end up with here is a negative 4y plus 3. They are not identical. These are not the same. We cannot continue to factor this further by factor by grouping. Okay, so this is what not to do. How do we get around that? What can we do then? All right, let's erase this and let's think about it. What happened is when I factored out a positive 2 from here, I ended up with what I needed as far as the 4y and the 3, but the signs were reversed. So how do I reverse the signs? How do I get a positive instead of negative and a negative instead of a positive? Well, the trick here is that instead of factoring out a positive 2, you can factor out a negative 2. This is the trick here. you can factor out a negative with the greatest common factor. When you factor out a negative, all the signs get changed. Let's see how that works. So once again, we have 5y cubed here, and that left us with 4y minus 3. And now I'm going to factor out a negative 2, so please be aware that there's going to be a minus here and then the 2. Okay, the sign in the middle is very important. That's why I kept stressing on it. Okay, so what happens this time? What happens this time is now we have a negative 2 that we factored out. So we're going to divide those two terms by a negative 2, not just a positive 2. So if I have a negative 8y divided by a negative 2, negative divided by negative is positive. So I get a positive 4y. Right here, I have a positive 6 divided by negative 2. Positive divided by negative is negative. That gives me a minus 3. Now, look at the parentheses. Now the parentheses are identical, and now I can continue my factoring. Please pause the video, go ahead and continue the factoring and do that one. Okay, hopefully everybody was able to finish this one. We are going to factor out the 4y minus 3. Open the parentheses. Here's my first term. If I divide it by 4y minus 3, cancel, cancel, I get 5y cubed. The second term, if I divide it by 4y minus 3, cancel, cancel, I get a minus 2. This negative is here, and I get 2. And this is my final answer. Please be aware that you can always know whether you have the right answer or not before you submit. You can simply expand or FOIL, multiply these two, then multiply these two, then multiply these two, then multiply these two, then combine the like terms, and you should be able to get this, what you started with, okay? So the great thing about grouping is, or the great thing about factoring in general, is that even before you submit your answer, even before you submit your test, you have the chance to know whether you got it right or you got it wrong. It's really cool. Okay, let's take a look at the last example. So the last example here, again, we have 4 terms. We know we're going to group these two together, and we're going to group these two together. The first two, if I group them together, what is the GCF? You guys can try this on your own if you're confident. The GCF here is going to be 2x squared. So if I factor this out, what do I get? I get 2x and then plus. So if I divide this by 2x squared, I get 2, and then I get x. If I divide this by 2x squared, what do I get? One more time, anything divided by itself is 1. So I get a 2x plus 1. Okay, that's our first group. Let's take a look at the second group. Is there a GCF here? Is there something that I can factor out? Well, the answer is no. The answer is no. I can't factor out any constant or variable, but let's take a look at what we have. I have a negative 2x minus 1. Well, what do I want? I want a positive 2x and a positive 1. So what is the trick that we just learned? The trick we just learned is that if I want to change the signs, I can factor out a negative. Okay? Now in this case, there is no other constant, so we can factor out a negative or a negative 1. So the GCF here is -1. If I factor that out, that -1, and I open the parentheses, what am I left with here? Divide this by -1, -2x divided by -1, negative by negative is positive, that gives me a positive 2x. What about the second one? If I divide this by -1, same thing, negative divided by negative is positive, so I get the +1, and now we have the same factor in the parentheses that we need to continue. Now please be aware that you don't have to write this one. 1 times anything is itself. Okay, so that's why we say that it's factoring a -1 or just simply factoring a negative. This can be written as -2x plus 1. That's the same thing. Okay, that is exactly the same thing. We don't have to write -1 times that. Okay, now let's continue. What is the GCF here? It is the whole 2x plus 1 in the parentheses. All right, so if I divide this first term by the 2x plus 1, what do I get? Cancel out, I get 2x squared. If I take this whole second term and divide it by itself, 2x plus 1, once again, what do I get? Anything divided by itself is 1. So I get a -1, and that would be my complete factored form. Please take the time to go ahead and FOIL that, okay? If you have forgotten foiling or if you're not confident that you can FOIL, please do so. Make sure that you know how to get this at the end. We are going to use foiling and reverse of foiling later on, so this is a good time for you to test yourself.